Hey, so I'm going to be continuing on with Chapter 6 review, and I'll be focusing on questions 24 through 29. So I have them copied out on a notepad, and I'll be working on them individually. Number 24, integral of 8x3 plus 1 over x dx. I'm going to take out the parentheses so it's easy for us to do the integral. Integration from 8x3 plus 1 over x dx. Before I integrate, I'm going to convert the fraction as a negative exponent. 8x3 plus, and this can be rewritten as x to the negative first power, dx. And then from here, integrate. And again, just be careful with how you do the integration process. You have 8x3, and I'm going to do the plus 1 and then copy and paste the 3 plus 1 here. Plus, this has a very specific name on how you're supposed to do the integration. You don't do the plus 1 and then you don't do the negative 1 plus 1, because if you notice, that becomes 0, and any number divided by 0 is undefined. But this has a very special name. We call it the natural log of x. I'll simplify this a little bit further out. We have 3 plus 1, 3 plus 1, 8x4 over 4 plus natural log of x. And I can further simplify this. This becomes 2x4 plus ln of x. Since we're talking about indefinite integrals, which has no bounds to the integration process, I have to incorporate that plus c always. On to the next one, 25. Drop out the parentheses, and this becomes integration of 4x plus 2ex dx. It's pretty straightforward from here. I'm going to integrate, and when I do that, I can drop out the integration symbol and apply the integration process. So it's 1 plus 1, because there's a hidden 1 in front, and 1 plus 1. Another thing to keep in mind is that the integral of e to the x is just e to the x plus 2 ex. Simplify a little bit further from here, and this becomes 4x squared, and 1 plus 1 is 2, plus 2ex. And I can further simplify this out. 2 over 2 reduce 4 over 2 reduces down to 2x squared plus 2x. And recall, since we're talking about indefinite integrals, I need to include a plus c, a constant value. (26) Trigs. Before we get started on working on trigs, it's best to write down that wheel, just so you can see the flow of where things are going. Sine, cos, negative sine, negative cos. When you go to the right, you're taking the derivatives. But when you're going in the other direction, in this direction, it's considered to be in the integrals. So we'll have to go counterclockwise so that we can take the integration. So let me erase this and follow the flow of the arrows if we're talking about integration, so like this. The integral of cos, this is my starting point, but then I need to go to 1 to the left. So the integral of cos is sine of x, include a 5. For sine, I start at sine. And the integral of sine, I need to go 1 to the left. So this becomes negative cos. of x. From here, I'll need to re-include that -3. Carefully work out the math. 2 negatives gives you a plus 3 cosine x. And this is 5 sine x plus 3 cosine of x. And since we're talking about indefinite integrals, I need to include that plus c. Onwards. 27. This is pretty straightforward. I'm going to quickly apply the integration process, so this becomes 6x squared. And to increase by 1 degree, but also divide by that 2 plus 1. 6x3 over 3. And that reduces down to be 2x3. And again, since we're talking about indefinite integrals, I need to include that plus c. '28. I think I consider 28 to be, no, I wouldn't say difficult, but you just have to remember your algebra rules. What I mean by that is that because of the power of 2, you can't take the integral unless if you have a substitution. But 28 shouldn't be that tricky if you think about it. X plus 1, x plus 1. Before we integrate, it's probably best to FOIL. First, outside, inside, and last. Add your like terms. You got x and x, and that will give you 2x. Rewrite everything else out. And from here, you're pretty much ready to take the integral of this polynomial. So we're going to do x squared. I'm going to increase it by 1 degree, and also divide by that original plus 1 degree. Plus, here's the original, 2x. There's a hidden 1 in front of the x, and I'm going to increase this by 1 degree. And the fact that this one doesn't have any x to it, we need to reintroduce that x back into the system if we're taking the integral. So it's x. Simplify this out a bit, so this becomes x to the 3 over 3 plus 2x, 1 plus 1, 2 over 2 plus x. And I can see we can simplify it just a little bit more. x3 over 3 plus x squared plus x. And again, since we're talking about indefinite integrals, I need to include that plus c. 29. This one's a little bit tricky if you don't know where to start the integration process. Many would want to skip out on dividing x and focus on the top. But the fact that we're doing a ratio of polynomials, it's probably best to split them up. X over x plus 1 over x. So all I'm doing is just rewriting this one fraction as two fractions so that we can take the integral of this. This is 1 plus 1 over x dx. Now it's pretty much direct to apply the rules of integration. Since there's no x, we have to reintroduce the x back. And just recall the integral of a fraction with the variable on the bottom, x. This becomes natural log of x. The fact that we're talking about an indefinite integral means that I need to include that plus c. What distinguishes 24 through 29 as indefinite integrals is the fact that they don't have any bounds to the integration process. If 29 perhaps was to discuss a problem like from 1 to 3, then 29 now talks about a definite integral. You can see the word define, where you have some sort of limitation to the function if we were to graph the x plus 1 over x. Something like this. You start at 1 and you go up to 3, 2, and 3. So you have an area. So if I was to extend a little bit further out on this answer, work with mine x plus 1 over x. And, we've already situated that the result was x plus natural log of x. If I was to apply the bounds, the fact that this is already the answer and we're defining an integral, then it is best to ignore this plus c, and then from here just apply the bounds from 1 to 3. So this is just like an extension. You won't be tested on finding the indefinite and then the definite integral of a function. And from here it's just a copy and paste. Plus natural log minus plus natural log. Apply your bounds, the 3, and then the 1. Simplify this a bit. 3 plus natural log of 3 minus 1 plus natural log of 1. Natural log of 1, if you type this into the calculator, it just becomes 0. So then you just have 3 minus 1 plus natural log of 3. Most of the time, many instructors and or the homework programs, they just prefer you to have the exact answer as the solution. It's not like you have to type this number out on the calculator and then have some sort of decimal number. In calculus, it's common to not use a calculator when finding weird solutions. They prefer to have the solution to be like 1/2 natural log of 1/8. As funky as it may look, many instructors would want this kind of answer rather than to have a decimal.